Alright, so I think the previous video got cut off, so I'm just going to restart with this baseball problem. Excuse me. So it says, several years of playing, the probability of throwing a strike, so P, the probability of success, is 0.65. So this means 1 minus P, the probability of throwing a ball, 0.35. N is a simulation of 100 pitches, so that's a sample size. And part A says, describe the distribution. Well, first thing I'm going to know is that these are random. It says that. It's a random sample. And we know that each pitch, or each sample, if you want to think about it that way, is independent. So each sample is independent, right? So like one pitcher does not affect another pitcher. So let's describe the sampling distribution. Well, N times P, 100 times 0.65, equals 65. And N times 1 minus P equals 100 times 0.35 equals 35. So since this is bigger than 10, this is bigger than 10, therefore, since the conditions are met, this is approximately normal. Approximately normal with mean equal to the p-value, 0.65, and standard deviation equal to square root, again this is given to you on the formula sheet, p 1 minus p over n, which is equal to 0.099. That's part A, describe the distribution. So you prove that the conditions are met, then you describe the distribution. Part B says, what is the probability that they throw 70 or more strikes? So the probability that X is bigger than or equal to 70. So this is 1 minus the probability X is less than 70. This we can do with binomial CDF. We talked about it. This is 1 minus binomial CDF. N, sample size is 100. P, probability of throwing a strike, is 0.65. And this right here is 69. Why 69 and not 70? Because when you do binomial CDF, it includes this number right here. We do not want to include 70, not equal to, so this becomes 69. This is straight on the calculator. And I'll just show it on one calculator. Now we've shown it on both. We did it in the previous example. So second distributions, we go binomial CDF, 100.65. This is 69. Paste 1 minus this gives me 0.1730. And there you have it. So that's describing distribution was part A, and this tells us the probability of having more than 70 strikes. Alright, and now let's finish up with the last problem, bottom of the page. It says a recently published study, right, reported that 63% of the students have some type of structured homework time. Local faculty surveyed 83 and found that 43 reported having structured homework time. Was the z-score? Alright, remember z-score is equal to x bar minus mu over standard deviation of x. This is on the formula sheet. X bar, well, 43 divided by 83 minus the mu, that's from the population, that's 0.63. Downstairs is the standard deviation of the sample, which as we just said is P times 1 minus P over N. So 43 divided by 83 is 0.52 minus 0.63, all divided by probability of success 0.52 times 0.48 divided by N, which is 83. And this is, let's take a look here, answer choice D. Answer choice D matches this. So that'll be the answer for the z-score here.